Hello friends, welcome back. In the previous tutorial, we wrote an algorithm to find the given number is odd or even. Then we translated the algorithm to pseudocode and then that pseudocode we translated to flowchart. In this tutorial, we take one more example problem for solution. We know that flowchart is a graphical representation of an algorithm or a pseudocode. It is used to graphically represent flow of execution of a program. Flowchart has some set of graphical shapes or geometrical shapes used to draw a flowchart. We know that there are two different types of persons who use computers, end user and a programmer. End user uses the computer to solve his problems, whereas programmer uses the computer to solve user problems by creating programs or by developing softwares. This time end user has another problem. He wants to give his name to the computer. In return, he expects that computer should display his name 5 times on the screen. So in front of the programmer there is another problem of displaying username 5 times. Now we need to understand and analyze the problem how to display username 5 times on the screen and then design a solution to the problem. Let's start and analyze. As user provides his name, we need to store his name in the memory. Hence, we need to create one variable to hold username. Next step is display enter your name on the screen. To indicate now user can enter his name. Once the user enters his name, we should store that name into the variable username. Next thing is we need a counter to keep track of how many number of times username displayed. Hence, we need to create another variable with the name counter. Next step is to initialize the counter to 1 to indicate the first time username is getting displayed. Then display the username. Then increment the counter by 1 to indicate second time username is getting displayed. Repeatedly we display the username and increment the counter by 1 until the counter value becomes 6, because we don't want to display the username 6 times. We want to display the username only 5 times. Once the username got displayed 5 times, once the counter value becomes 6, we stop the program. Now we have analyzed the problem. Let's write an algorithm. Here I have already written an algorithm to display username 5 times. The algorithm is something like this. Start, declare a variable username. Of course, we need a username variable to get the username and put that inside the username variable. Next step is display enter your name colon. Once the enter your name colon got displayed on the screen, user understand that now he can enter his name. So user will give his name. That name we need to read and put into the variable username. Next is to create a variable counter and assign a value 1 to the counter variable. Next, repeat step 8 and 9. Repeat step 8 and 9 until the counter is less than 6. Once the counter becomes 6, we need not to repeat the 8 and 9 step. We can go to the step 10 and stop the program. This is an algorithm, very simple algorithm you can see here. This algorithm we can translate to a pseudocode easily. With respect to the basic programming language, we have written a pseudocode here for the above algorithm. First step is start. Next, dim username, define username, then print enter your name colon, read username, dim counter, initialize the counter to 1, so counter equal to 1. Then we use the while keyword for repetition. While counter is less than 6, then print the username and increment the counter by 1. Before end while, go back and check whether counter is still less than 6. If it is less than 6, print the username and increment the counter by 1 until the counter becomes 6. Once the counter becomes 6, this condition evaluates to false. Once the condition evaluates to false, end while and go to stop. That's it. That is how the code works. This pseudocode can be easily translated to the flowchart. You can see that here we have translated to the flowchart and we understand the flow of execution of the program easily by seeing the flowchart. We know that oval shape indicates the start and end of the flowchart or start and end of the program logic. You can see that start we have written in the oval shape. After executing the start statement, computer moves to the next instruction, that is dim username. You can see here we have used a rectangle shape to write or to declare a variable. A rectangle shape indicates the process of declaring variable, initializing the variable, etc. So here you can see that we have declared a variable username. What computer does? Computer is going to create a memory location with the name username. So what computer does? It creates one memory location with the name username, username, username. Then computer moves to the next instruction, print enter your name colon. You can see here parallelogram is used to display output instruction. So here we have written output instruction because parallelogram indicates the input and output operations. Print enter your name colon. What computer does? It displays enter your name colon on the computer screen. Control V. Enter your name will be displayed on the computer screen. Once the user finds that enter your name colon on the computer screen, he understands that now I need to give a value. Let's take the user has given the name Suresh. His name is Suresh, so he entered the Suresh. Next, the computer moves to the next instruction, read username. You can see that the input operation, read username, is the input operation that we have written in a parallelogram because parallelogram indicates the input and output operations. Read username. What this statement does? It reads whatever the user has given and puts that into the username. What computer does now? Computer takes that username, reads it and puts it into the username variable. Next, computer moves to the next instruction, dim counter. So we have used the rectangle shape to put dim counter, that is declaring a variable. We know that rectangle shape is used to indicate operations like declaring variable. So we have written declaring a variable in a rectangle shape. What computer does now? It creates another memory location on the memory or in the memory you can say with the name counter, counter, counter. Once the memory location is created, computer moves to the next instruction, counter equal to 1. We know that rectangle shape is used to indicate the assignment statement also. You can see that counter equal to 1 is the assignment statement. We have written that in the rectangle shape. Counter equal to 1. What computer does now? Computer puts 1 inside the counter variable. Then computer moves to the next instruction. You can see here I have used the hexagon shape to write counter is less than 6. Instead of using the diamond shape, you can see I have used the hexagon shape. Why? Because the hexagon shape indicates the looping statements. So counter less than 6 is actually a looping statement here. So while counter less than 6, we can read it as while counter less than 6. You can see here counter is 1, 1 is less than 6 is true. As the condition evaluates to true, the flow will be like this. Computer executes the true part. So here you can see print username is written in the parallelogram. A username is going to be displayed on the computer screen. So what is the username? Username is Suresh. So Suresh will be displayed on the computer screen first time. Then computer moves to the next instruction, counter equal to counter plus 1. So whatever the counter is at present, counter is 1, 1 plus 1 is 2. So counter is going to be incremented by 1. Counter becomes this time 2 instead of 1. Now the counter is 2. After executing that statement, computer goes back to the condition as it is a looping statement. Again, whether counter is less than 6, yes, counter is 2, 2 is less than 6 is true. As it is true, once again username will be displayed on the computer screen. Once again username is going to be displayed on the computer screen, and then the control or computer moves to the next instruction, counter equal to counter plus 1. So this time counter is going to be incremented to 3. Counter is going to become 3. Then again control goes back and checks while counter is less than 6. Of course 3 is less than 6 is true. Once again username will be displayed on the computer screen. Then the control moves to the next instruction, counter equal to counter plus 1. So counter becomes now 4 instead of 3. We are going to have counter value 4. Then again control goes back while counter is less than 6. Counter is 4. 4 is less than 6 is true. Once again username is going to be displayed on the computer screen. Then the control moves to the next instruction, counter equal to counter plus 1. So this time counter is going to become 5. Counter is going to become 5. Then the computer moves back and checks whether counter is less than 6. Of course 5 is less than 6 is true. As the condition is true, it displays one more time username. So we are going to see one more time username on the screen. Then counter equal to counter plus 1. So this time counter becomes 6 instead of 5. We are going to have here 6. Then again control moves back, or computer moves back while counter is less than 6. This time counter is not less than 6. Counter is 6. 6 is equal to 6 is true, but 6 is less than 6 is false. As the condition becomes false, instead of going to true part, control moves to the next instruction, false. So it goes to the stop instruction and program terminates. This is how we write a flowchart, guys. This is how the flow of execution of the program works. I hope you guys have understood how do we write an algorithm and how do we solve a given problem by creating algorithm, pseudocode and flowcharts. So I suggest you people to try more flowcharts for more problems, create some flowcharts, analyze some problems, understand how to write algorithms and pseudocodes. For this tutorial, this much is enough, friends. In the next tutorial, we get more information. For more benefits, please subscribe and don't forget to like, comment and share these videos with others so that everyone will get benefited. Keep learning, keep coding, keep sharing.